the first garden with watermelon. Shade in 1/10 of the first garden with watermelon. And let's say that I shaded in 1/10 of the next garden, 1/10 of the next garden, the second garden with watermelon, and the third garden with 1/10 watermelon. Okay? So, what are all the ways that we can use decimals, fractions, and percents to describe how much of each garden I've planted with watermelon? So let's look at the first one. Tim, what'd you do for the first one? I said 1/10 of the garden is planted with watermelon. What did you do? Okay. Am I doing it correctly? Okay. So, that's what I shaded. What would, give me a decimal or a fraction or a percent that would represent the amount that's shaded? 10%. Okay. Give me something else, fraction, decimal, that would represent that amount shaded. Jillian?
0.1.
0.1. How do you name that with a decimal? It's 1/10. What else do you know? Anybody have a fraction for me of the amount that's shaded? Clark? 1/10 or 1/10. Good. Let's look at the second garden, the one that's divided into 100 parts. If you shaded 1/10, what did you do? What did you do to shade 1/10? Ernie? Shaded in the first row or one of the rows. It doesn't have to be the first one, but it's nice to compare the two, right? Who can give me some decimals, fractions, or percents for this one that represents the amount that's shaded? Spencer? So you shaded one row out of how many rows? 10. So you shaded 1/10 of the garden. Is there anything else that you did, Courtney? 10%. There are 100 squares. How many squares did you shade, Hannah? 10 hundredths. Anything else? What about decimal wise? What did you shade, Kennedy? 0.10 or 10 hundredths. Did we shade? Do you agree that both of these are the exact same size garden? Did you shade the same amount in the garden? So would we say that all of these numbers here are equivalent to all of these numbers here?
Well, of course.
How many hundredths is equal to a tenth? How many of those 100 squares does it take to equal 1/10? Elise? 10. So what we're saying is it takes 10 hundredths, takes 10 of these squares to equal 1, that was a big one of these squares, right? So 10 hundredths is equal to 1/10. Let's move on to the next one, the thousandths. When I said to shade 1/10 of the thousandths garden, what did you do? Amanda? So you just shaded in one little thing here? If I say 1/10 of the garden, what I'm saying is I'm breaking it up into 10 equal parts, right? So if I break up this whole garden into 10 equal parts, what am I going to shade for 1/10? Am I changing the amount that I need to shade? No, I still need to shade 1/10 of the whole thing, right? So is that going to change the amount that's going to change? Tim?
2 squares?
2 squares? So you're saying 2 of these?
Yeah.
Well, wouldn't that be 2 hundredths?
No, that would be because each little square has 5.
So, okay. So, if each one, actually each little square has 10 in it, right? But we want 1/10 of the whole garden, right? This is the whole garden. I want to divide the whole garden into 10 equal parts. So what am I going to do? What? Hannah?
You do like 10 boxes.
Has it changed? I'm still shading in 1/10 of the whole garden. 1/10 of the whole garden is still going to be planted with watermelon, right? 1/10 is planted with watermelon here. 1/10 is planted with watermelon here. 1/10 is planted with watermelon here, right? Still the same thing. But in each plot, for example, here's this plot, okay? They're cut up into smaller pieces to equal the whole thing. So, for example, let's think about this in brownies, okay? Which brownie, if you had this one, or this one, or this one, who's eating more brownies? Kaden?
Nobody.
Nobody. They're all the same size. This is the same size as this, which is the same size as this. But with this one, it's a really big piece of brownie, right? With this one, they've cut them up into smaller pieces, but you're still eating the same amount, right? Think about it. If you have a pizza, right? And you have one big, huge slice. Or, because sometimes, like for example, which pizza place has squares? Little tiny squares. Domino's. Does Domino's have little tiny squares? Okay. Which one has triangles?
Oh, Papa John's.
Pizza Hut. Pizza Hut. So, if I say that I ate one piece from Domino's and one piece from Pizza Hut, did I eat the same amount? No. But here, they're showing you that you started with the same amount, right? So if you want to eat the same amount as your brother, okay, then you have to eat a lot more, not a lot more, but the slices are smaller, right? Okay? So you're still eating the same amount in all of them. They're just cut up into little tiny pieces, right? Think about a loaf of bread. Those big French loaves of bread. I could take it and like, okay, for dinner I'm eating a French loaf of bread. Now, it'd be really silly if I'm sitting there with a big, huge French loaf of bread just sitting there eating it. Hey, guys. Okay? Or, if you go to the bakery, they could say, do you want this slice? Well, somebody's probably going to say, no thanks, I'm just going to eat it by the loaf. Or, somebody could say, yeah, can you cut that into 10 equal slices? Now, if you cut it into 10 equal slices, they're still going to eat the same amount. They're just going to eat it in slices, okay, and eat 10 slices versus eating a whole loaf of bread. So they can eat, right? For here, you're still eating the whole loaf of bread, but now you've taken it, cut it into 10 slices, and then taken those slices and divided it into chunks, and you're still going to eat the whole thing, okay? So you're eating the whole thing. It might take a little bit longer, right? But it's still the same amount. Give me something that represents the amount that we ate here on the thousandths chart. Give me the percentage of the whole thing that you ate. Lily? Percentage.
Oh.
10%. You're still eating 10% of the whole thing.